Hi everyone, please take a look. What you're seeing is a picture of part of the universe. The universe, this fascinating beauty, is explained by one theory, the Big Bang theory of the universe. Now, the Big Bang theory of the universe is widely accepted. It is accepted by the National Aeronautic and Space Administration (NASA) and the European Space Agency (ESA). In discussing the Big Bang theory of the universe today, I will cover the beginning of the universe, the Big Bang, and the era that followed the Big Bang. Now, let us begin. Let us start with the beginning of the universe. The universe began as a tiny, hot, dense point. Conditions in that tiny, hot, dense point were extreme. Temperatures and pressure were infinite. Next, let's discuss the Big Bang. The Big Bang in this case means a big explosion. Looking back in time, about 13.8 billion years ago, the tiny hot dense point exploded, and from the explosion came three-dimensional space and one dimension of time. Forces such as gravity, weak, strong, and electromagnetic forces were also released. And these all happened about within 10 to the negative 43 seconds after the explosion. After the explosion came the era, radiation era and the matter era. First was radiation era. Radiation era was full of forces and energy. With all these conditions, the universe cooled a little bit down. So subparticles such as electron, neutron, and proton were formed. To give you a quick idea of what is a subparticle, these are proton, neutron, and electron. These are the subparticles. These subparticles formed during the radiation era, and the radiation era only lasted for about 100,000 years. After the radiation era came the matter era. With energy and subparticles formed during the radiation era, the matter era was able to create its first atom, hydrogen and helium, and this happened within the first 1 billion year. The matter era created so much of hydrogen to a point that hydrogen make up 73% of all atoms in the universe, and helium by itself make up 25% of all atoms in the universe. Now, once hydrogen and helium were created during the matter era, they came under the force of gravity and formed many big clouds that are called galaxies. Now, inside the galaxy, forces of gravity and other forces act upon these newly created atoms, hydrogen and helium, to form stars. Now, once stars were formed inside the galaxy, stars now became the factory to manufacture all the rest of the natural atoms that we know today in the universe. Now, how did stars form that? They formed that through a system called nuclear fusion inside the star to create all these atoms. Now, some of the stars, at the end of their life, they explode. Once they explode, they release all these atoms into the universe, and how this is how gravity is able to collect all these atoms that were released after the explosion of the star to form objects of such as our planet Earth and other planets, and also things like human, animals, and trees also use all these elements that star created to form the visible universe that we see today. Now, to give you a brief overview of what I just said in a picture, please take a look. As you can see here, down here, this is the Big Bang theory, the Big Bang that occurred, yellow and red, that's the radiation era, and the blue part is the matter area. You can also see our planet right there, part of the matter area. The same thing also is here, the Big Bang here, radiation era, and the matter era. Now, let's recap what I just said. So, we discussed the beginning of the universe, where a tiny hot dense point started all these things. We also discussed the Big Bang, when the tiny and hot dense point exploded. And finally, we discussed the era, the radiation era, that formed the subparticles. Now, the matter era used whatever was formed during the radiation era to form all the rest of the universe as we know it today. Now, the Big Bang theory of the universe not only tells us the story of the universe, it also tells us that we humans are simply stardust. Thank you.